people use 3.1. Is that still a thing? Or I'm sorry. Yeah. Anyways, and you can install packages, configure the container, adjust how you'd like. And as we were building these kind of two services, we realized that between the two of them, the use cases are largely similar. Cloud Shell, there isn't actually an IDE on the front of it. In Code Catalyst, there is an IDE that you would connect to it. We also provide the Cloud9 browser-based IDE. So for the two externally facing, externally being customer-facing services we offer, there's a few slight differences, but under the hood, it's largely similar. So we assume that the solution to this would also be very similar from like a technical perspective. And then there. Oh, no worries. Yeah, so we assume that the technical solution will be largely similar. The main items we wanted to make sure that we covered were that ideally it would be container-based. We were building this in late 2020, early 21. At the time, containers were kind of the de facto way of building these isolated environments. I don't think that's changed recently, but at the time, that was our main driver of this is how you create these isolated environments. We wanted the ability to also define multiple environments with some kind of orchestration. So if you're creating a developer environment in the cloud, let's say you're working on a microservice architecture and you want it to interact with some database that's running somewhere, you'd like to be able to spin up that database as like a separate container to give you that strong isolation. Otherwise, you have to have your development container that also has a database running in there. Then you're worried about resource contention, it's hard to profile, and it drifts away from this idea of your dev environment looking very similar to your prod environment. So if we had the ability to orchestrate bringing online multiple containers, that would be great. And we weren't certain if we would want to expose this standard directly to customers, but we wanted to leave that door open. We talked about one-way and two-way door decisions. We didn't want a spec that would be hard for people to parse or require specialized tooling to parse. So ideally it would be YAML or JSON, something human readable. It's kind of the difference between like C and Python in terms of readability. We didn't have a strong requirement that we must expose the spec to customers, but we didn't want to get into a situation where we couldn't do that because we chose a spec that was indecipherable. And finally, we didn't want a solution that required an IDE be present. There were some that we'll talk about in a moment that had specific configuration options that assumed that an IDE is always present. And as I showed on the Cloud Shell example, it doesn't have an IDE. It's a very simple terminal on the front. So start looking at the existing formats that are existing there. And before I start on this section, I'm going to describe like the things that we liked and didn't like about this. This isn't meant to imply that any of these standards are bad or not good, or the people who built them did something wrong in any ways. It's just for our use case with that standard, these were the gaps that we found or things that we thought we could improve on. This in no way is meant to disparage the work done by these teams. It's just aligning this to what we wanted to do. So first was Docker Compose. It seemed like it was better for those targets of the developer environment. When you open a developer environment and you want to create a database instance, you want to create some other mock microservice endpoint, Docker Compose was really good for that, but it felt a bit too low level for us. But it did look like it could be part of the spec, part of the solution overall. Next was this devcontainer.json, which came from VS Code uses. It's built on top of Docker Compose, what led us to that. We wanted something a bit more high level. What I really liked about it was that it had this opinionated way of injecting environment variables into the application. I think it's the common format of $, like squiggly brackets. We'll talk about that in a few moments of like why that was important. But it didn't require that being the way to do it, but it was also heavily opinionated, which I thought was useful. It gives you the ability to extend the framework, extend the spec without creating something that's non-compliant. My main concern with that is that it also had a separate metadata file, a dev container metadata file. And from my perspective, the spec we were using for the dev environment is a metadata file for itself, and now it has its own metadata file. So it feels like that scene from The Office with the cupcakes, where it's like a cupcake is a mini version of a cake, and there's mini cupcakes. It felt like going the wrong direction. So we kept looking. Gitpod, I love using Gitpod. They they had several. Start with the parts I did like is it allowed like a list of tasks that you could run. So once the container was up and running, you could run a set of commands against it and allow that in like a list format. So it's very easy to see it's going to do this and then this and then this. And the downside is they had a separate entry for every type of IDE. So it would require a lot of coordination anytime a new IDE is created. So if JetBrains creates, I think they just launched a new Rust one, right? JetBrains is good because they tend to consolidate those, but if we get new IDEs that come into the market, we wouldn't want to have to go back and update the spec and then worry about a migration, backwards compatibility in these items. So a lot of it was tied specifically to like Git repositories, which for the Code Catalyst dev environment, that could make sense if we want to connect it to a Git-based repo. But for Cloud Shell, it wasn't connected to a Git repo, so it wasn't too clear how we would make that work, or if we could make it optional and how it would affect the rest of the community if we collaborated with them. Then I even looked at Conda's environment.yaml file. So what I really liked about this was that I don't have to say sudo apt get install and like have very detailed complex installation instructions. I can just list the actual dependencies that I want. The downside to that is that it's because under the hood it's handling the actual installation, it's limited to things that you can just do like pip install. What I assume it's doing is just substituting that in and a variable substitution in a pip install. So this is great because I'd like to be able to have customers who can say, I want Python 2.7 or I want Java 11 and just say Java 11. They don't have to do like the weird curl bash to like get the dependency and install it and make, and this guy's nodding his head, so he's probably done that a few times. I really liked this style. It's just it was too limited in terms of like the breadth of what it's for. There is no version of this that works for Java or Rust or JavaScript. And then finally we landed on the dev file. The dev file is a open source spec that was created by Red Hat. They fostered it and they introduced, I think it's in the CNCF, is like managed by the CNCF. I'm not 100% certain on where it lives today. But it was originally meant as a container orchestration thing for Eclipse J, which is their open source IDE, cloud-based IDE. And because it was purpose-built for an IDE, it solved most of the things that we needed it to do. They had this IDE configuration option, which we wanted to make optional because we wouldn't always have an IDE available to it. It has commands that are kind of human-friendly, so you have commands that you can give it that are part of the container initialization process, and then you can say once it's online, also do these other things. So you can easily separate that out into before the container comes online and after. If you're setting environment variables, for example, is one you'd want to do afterwards versus making sure that a specific file exists, that maybe you want to make sure that's there from the beginning. So the gaps we wanted to cover is we wanted a common format that supported both inner loop and outer loop development. So the inner loop is the development that you do as part of kind of writing some code. You make a change, does it run now? Does it work? Does it build? Make a change, does it build? Kind of back and forth. In order to do that, sometimes it'll need connections to these other containers, like the database instances. And then outer loop is where you create a commit and then push it and have it kind of run through your pipeline, through a QA pipeline or some other thing that tends to be much slower. I think about it, inner loop should be done in under 3 minutes. Outer loop could be a few hours. What we were trying to get towards is that you'd have one specification file that could have both of those, because it'll give you the ability to reference one from the other to keep them as similar as possible. You don't want one set of commands that you do to build it locally and then a completely different set of commands you do to build it in your build system when it's being deployed. There is certainly use cases for those being slightly different, but if they were completely different, it would just create a lot of friction. We're artificially coupling these two when they shouldn't be, but ideally they would be the same. And we wanted a format that would support that. Because it was container-based, we were largely wanted something that worked with Docker. At the time, the dev file only had a Kubernetes pod management plugin and not a Docker container orchestrator plugin. And then finally, we wanted something like a registry. If we were creating a new spec or significantly expanding an existing spec, we wanted customers to be able to kind of understand how it worked, to kind of play with it, and also have a lot of common examples that they could kind of reference to see how do I do X, Y, or Z. And we thought a registry would address that. So we reached out to the Red Hat team. There's Mario, who's a principal engineer in Red Hat, who worked with us. So the first part was the inner loop development. So there's a separate, this part, I probably should put it at the end. It's a bit fuzzy on like the exact work that was done. It was more of like influence into how the spec was defined. When we launched the product, we weren't entirely certain that this would be delivered, but we knew that they'd understood the use case and they were working on a solution for it. And it had explicit support for both inner loop and outer loop development. So this is just showing the inner loop part. Yes, and there's also an outer loop part where you can specify other containers, other things that are needed as part of like the build action. Separately, we built a CLI plugin tool for the Docker API. At the time when we started, just the Kubernetes API was supported by the dev file and by the tools that existed. This wasn't actually a part of the spec. It was a thing that understands the spec and then maps it to a Docker API. And we built that and contributed back, and now it's maintained in the open source repo on GitHub for that. And then finally was the registry. This is the public dev file registry. It was created during our collaboration to give people a place to launch, your .NET examples, Go, Python, Node.js, to show very basics of how to get up and running. And then some of the takeaways we found is there was a lot of temptation to like start with something that's open source, and if it doesn't work for us, we can just fork it and maintain our own standard, and we'll just stop being open source, or we'll stop kind of collaborating if it doesn't work. You have to, in order to prevent that, you have to kind of start by setting the expectations that like we think this standard is what we need or very close to what we need. Any changes we make to this, we should be making for the better, and we should work very diligently to get them into the spec and make sure that we're not doing any things that kind of compromise how useful the spec is to the broader community. If you find yourself in a situation where it's like, oh, we'll just fork it so it supports our thing, you're probably trying to insert a kind of you-specific thing into there. So please avoid that. And this is where I talk about the environment variables. You want to balance. A spec can clearly say this is exactly how you must do this thing, versus it's just a string. You can put anything you want there, and if we go back to the tools, like one tool might support it, another one might not. The balance you have to strike there is by making it part of the spec. People who build additional tools will know exactly what they can depend on, what will or won't change. If you make it kind of strongly opinionated, people can be a bit more flexible with how they use it. And I'd love to say I have a really good answer for that, but like it comes down to feel, for lack of a better word, of like, does this feel right? Is this a thing that someone could inadvertently make problems much worse if we don't have strong guardrails in the form of the spec? Or is it a thing that we're okay with them being flexible and how external variables are referenced? What we were really worried about is if we were kind of too much on just the opinionated side, we say, okay, well, environment variables are injected with like double curly brackets. And then someone else said, well, I want it to be $ curly brackets. And another team said, we want it to be like double angle brackets. Now every tool that exists either has to support all these random things, or none of them work, because you have a spec that only works for your tool. We ended up leaving this in the strongly opinionated category, and I think Docker Compose is the dev container JSON is similar. But the community itself has settled on the $ curly brackets, which I think is the best possible outcome. It isn't formally defined in the spec, but everybody does roughly the same thing. And that's where places like the registry come in handy, because that kind of enforces some of these group norms and idioms and best practices without mandating that people do it a very specific way. And then most of the work that was needed wasn't writing code for the core product. We spent almost no time writing things or specs specifically for the spec. We were creating tools for supporting the spec. We were creating tools for supporting extensions of the spec so that the spec could be extended. This is work that often gets kind of under-recognized. You create this API plugin that allows you to use this with Docker. Most people don't see that unless they specifically have a need for Docker support. But if they do, they love that it already exists. But again, it's not part of the core spec. So I found that we'd have to go out of the way to make sure that we recognize some of these items of creating examples for the registry, creating these plugins. We always talk about how you can update documentation. That's an equally valid contribution. It's even more true in this case. And that is the end of it. So I can take questions. Thank you for joining me. My email, if you have anything you don't want to say to me in the room because everybody will get mad at you, you can just email it to me. And thank you for coming. Yes. Cool. Any questions? No questions? None? Yes?
What kind of projects do you find people typically using this for?
Oh, yeah. So the question was, what kind of projects do people typically use this for? This is specifically for if you want to create a cloud-based developer environment. So it's container orchestration, and like the specific case of that container is being used for developer environments. So you can have a container for Kubernetes where it's managing a database, right? The amount of interactivity you need, like with the files on the thing for a database, is much different than the amount of interactivity you would need for a developer environment where you're running, chown or changing directories, making directories, building stuff that creates artifacts that you then need to get off of the environment. It tends to need a lot more like kind of network I/O because you're, depending on how the IDE that's connected to it set up, it might push a lot of data and pull that back to render it appropriately. So yeah, it's specifically like cloud-based container orchestration that's focused on kind of like a developer inner loop use case is the most common. And I could just be biased and like that's what we were trying to do, so that's what we were focused on. There could be other use cases for it. But we have seen that the dev file has shifted over time from a thing that creates a container, like a single container for a single IDE, to a thing that can kind of orchestrate and bring online in the right succession and pass values from one another for like multiple IDEs. So it's not necessarily just pinned to like the developer workflow. Yes?
Two questions.
Okay.
The first is, how do you determine that you should go look for another spec rather than just coming up with something internally for a service that's functioning an internal service for you guys?
Yeah, so the question is like, how do we know we needed an external spec instead of coming up with our own? As part of building like the initial prototype, people had started using something like Docker Compose in that, and it was easily identified as the thing that they'd want to replace. So evaluating some internal specs was on there. I just didn't include it in the presentation, so I didn't have to bore you with like internal specs that we use. We have our own configuration system that we use that we tried to use that originally. The challenge with that was that we would then have to publish that. We wanted the ability to make it readable by the customer so they could set their own. So we would have to like publish that spec, and because that spec was that we were planning on using that was internally available, we'd have to fork that or do like extra work for maintaining that. And it soon became clear that the amount of work needed to create all the infrastructure for supporting a spec, so you have a GitHub repo, you create governance and some things around it, would have been significantly more work than even if we had to go beg someone to help us support them to extend their spec.
And do you see a future where dev file and dev container specs merge? Or do you think they're definitely divergent for different purposes?
I mean, in an ideal world, yes, they would. I would see them. So your question is, do I see a future where dev container and dev file specs merge into one? I'm just repeating it so the mic picks it up for the recording. Yes, I do see a future where they could merge. I would like to get to that point. They're very similar. The amount of overlap is very large. The things that are unique between them is small enough that I could see them merging. I could also see a use case for people to say, well, the dev file is a extension of Docker Compose or the dev container.json, just because it's roughly the same thing but focused on the developer environment. The main thing we saw with the dev container.json is it was focused on kind of not losing data during like replacing one container with another. If you have a service that's running, you need to swap out a container and move things. For a developer, that's less of a concern as it is for like a production database. I mean, developers don't want to lose data, but like it's less of a concern than a production database or a connection to a production database going down. So some of the things that they've optimized for are different enough. I could see them remaining separate, but there is room for them to be closer together in terms of one being just an extension of another. Cool. Awesome. Thank you all for joining me. It was I think, is lunch next? No, there's another session, then lunch, right? So I'm going to get lunch next. I'm hungry. All right, cool. Thanks, everybody.